Hello everyone, welcome to the class. Today we're going to talk about a special registers. It's called stack pointers registers. These registers in assembly, and we will talk about how your assembly, how your machine actually deal with the function call and function return, and something like the push, pop, this kind of stack stuff. Okay, so these registers we talk so far, we have two categories of registers. One general purpose registers, another part is more special purpose registers. There's a one called ESP, one called EPP. Actually, what's the ESP? Stack pointer. So the stack pointer registers is kind of a key of this assembly, this machine to manage your system's not the data and how your program actually run. It's all relies on this uh, because if you understand the function code, function return, you will know we use stack to implement to support these function code, function returns. So this is kind of idea uh, of our memory. So in the memory, we use the memory to store the instructions, which is your code. Your code get translated to a machine code, and we put the machine code in this memory area. So you can get the each instructions from memory to do a fetch, to do a decode, to like understand what you want to do for this. Another part is called stack. Stack try to manage your function code, function returns. Okay, so we will talk about the details in other videos, but just kind of imagine you have a stack, these data structures in your memory to support the data store and return. And the EXP list registers is actually try to remember where's the address of the top of stack. So what's the address of the top of stack? And in this case, actually, this is the largest memory address. This is smallest memory address. We just kind of get this in a reverse way. Just keep in mind there's some like different orders when we look at the memory address here. But the idea of the stack is the same. Even though we try to go down here, but actually we try to go up because the smallest edge is here, right? So we try to go up. So we call this is top. Here is top. And the ESP, these registers always point to the top of your stack in your systems. So this is a concept. Okay, so if you understand the stack here, this is the idea how to use stack. If we have, there's a source code in assembly, there's a code called push something. And the something we can use some different idea. For example, we can use, again, we can use this as a registers EAX. We can say it's dollar sign for number four. We can do EAX, we can do the memory part, and we can do some shift of memory part. We can kind of do this. So, but what's this push actually do? Try to store the data into your stack. So if we try to push the number four, then actually what it's actually do is you try to get the number four stored in your stack and move your ESP, these this register to here. How to move? Actually, your ESP will remember the memory address of this memory stuff, the stack here. So you store the new memory address to ESP. Make the ESP point to the top, still point to the top of stack. This is called push. When we do a push, we actually do this. When we do a pop, it's different. If we try to do a pop, it will get the data out from the stack. So it will get that data 4. So the data 4 will be returned for a pop. Then we will move the ESP back to the original memory address. So this is called pop. So we have push L, source, and pop with different assembly codes can help us to manage this ESP stuff. And this ESP stuff is automatically increment or decrease when you call these operations. So why we say special? Because we actually there's some operations they will work on these special registers without any indicators by the user. So you don't need to say the ESP, it will get automatically update. Okay, so we can do a push and pop. If you understand this concept can be applied to the function call and function return. So what's the function call and function return here? The function call function return actually working in the same way, except the function call, because you want to jump to different position of your line. If you have a line 100 lines of code, your first function start from the line 1, then the second function start from the like a 30, then you need to jump from the any like lines in this function 1 to the function 2. So you change the order of the, it's not run line by line, it's run from this line to other lines in the source code. So we call it jump. Okay, so if you do the code value, it will jump to this memory address. The idea of the code, if you want to do a function code, it's actually just call a label, and this label represent a different memory address in your source code. Okay, so in this case, if we try to interpret this one in assembly, it's something like this. In a main function, we call another line of a code here, which might be in a different function. Okay, so this is for a code. What it actually do for a code? If you want to call other function, this is fine. Just jump to different place. However, when you finish the function code, your function 1 call function 2 and function 2 finish, where the function 2 return? It should be returned to the next line of code of current line, right? So if you have a line 1, line 2, line 3 go to the function 2. After function 2 is come back, you should run the line 4, right? So in this case, we need to remember the return address, the next line of the current line. When you call a function, you need to return it. So how to implement it? In your code operations, it will store this return address in your stack. So it will push your return address to a stack. So what's the call function actually do? Actually, it's equal to push L, the return address. You got your return address. Then next line, you jump to a label. So the idea of the code is actually equal to these two lines. You push your return address, then you jump to a label. So you also use stack to maintain, you maintain your return address in the stack in this case, okay? So when you do a return, you can pop the address, memory address from the stack because you store it. Then jump to the stack, jump to the address. Then jump to this address because this address is the next line, next instruction you want to execute. Let's take a look over examples to see the details, how it's actually do, okay? So in this example, we have a stack here. This is stack. And we have an ESP, this is a stack pointer. And we have another part called EIP, another special special like registers. So what does this actually do? This is actually a program counter. You don't do anything about it because it's a program counter. Understand, like try to save which line you want to go next. Okay. So before we do anything, actually it's look like in this way. The ESP point to the top of your stack, right? So the number 0x10a equal to this one because the ESP point to the top of the stack. And the next line of your instructions, which is this line. And this line, we don't know what this means, but we know because we want to call other function, so the next line will be changed, not be the EIP anymore. Okay, so when we do the call function code here, this line, what's we want to do here? We know first of all, you need to do a push. You need to remember the return address. So we got the next line of this one as a return address. So we push the value 0x a0 a5 53 4e plus 4 equal to 53. So next 4 bytes of the instruction we push into here. So when we do a push, is affect to ESP, because ESP right now should get 104. This is the smallest one, right? If you remember the top. So right now we want to change this one to 0x104. So because we manipulate the stack, so we need to update the ESP will get update for this. Then we jump to the next one. So if we want to jump to the label here, we will change this one to 0x A04AB96, because this is the next line you want to execute. You want to jump to different function, execute the next function. So your programming counter will remember the next instructions you want to store. But here's the way: if anything here is disappear, how you get back when you finish the function? Don't worry, because you have this part, right? You already remember the return address. So after you do anything for this, for this function, you just got everything here and finish. Then you want to do a pop. What is actually do? It's try to do a pop of your value stored to next instruction. So it's actually do is okay. I already finished this part. So right now I should do a pop here into this EIP. So I will store everything here to 0xa04A553 here, because we pop the data. Then because we do a pop, we remove this line, which means we also update the ESP back to the regular state. This is the return. So when you do a return, actually you just try to get the data you store in a stack. Use the data as the next instruction you want to execute. Then update your ESP, because you want to pop the data from a stack. So you need to update the top of your ESP. This is a basic idea of how you manage your stack when you use a call function, when you use a return function, when you use a push, when you use a pop. Okay?
Yo, I have a questions. If I do the function call, but after function call, I also do a lot of push. In this case, if I forget to do the pop, I just call return. How our systems find the return address? Because a lot of data on the stack is not a return address. They are just something I do the push the data from the registers, so it will cause it cause a problem.
Actually, this is very good questions. If you just use a lot of push, and after you do the push, you forgot to do the pop, then you try to do a return, it will cause the issues. So when you run the program, when you write the assembly like this, you will cause a problem crash, because you try to make the program jump to some the data you just push. So the data can be anywhere, can be a nonsense memory address, right? So it might cause problem. That's correct. So to avoid it, actually we have another way to manage the stack, manage these call function returns, to avoid this weird situation. We try to use something else to support these call function return. And let's take a look of how to do it. So now we have stack pointers to help us to remember what's the top of the stack. It's very important. It's very useful. But if we can have another registers to support, to remember where's the button of your friend, of your previous function, then it can give you more flexibility, right? So actually, we have another information. It's called EBP, another special purpose pointers. We call it best pointers to support these stack updates. So in here, we have a ESP point to the stack, the top of stack. And if we do the push of we do like some other function code, we will update ESP to point to the new place, right? In this case, if we can have a EBP, this pointer to point to the previous one, the previous top, then we will know what's what's it actually look like. So you will get the kind of the whole range of your uh, uh, previous like functions. You will have all information about this. Then even though you try to do a lot of push, you can still try to like find out where's the new stack, where's the new top of the stack, because you remember this here. So even though I try to do a lot of push here, I can always find out the previous stack by use the data in the EBP. If we do a pop of EBP, right? So this is the idea to support your function call function return. And when you write the assembly code, this can help you a lot because every time if you afraid to forget, you don't remember how many push you actually do, you don't need to worry because every time you want to go to return, you just pop. You just get the pop of this EBP, then you can return to the data you store in this EBP, right? So here's the example. In this example, we just simulate how to do a function call and function return. So here we have a U, this function. This U function will call foo function. This foo function, when you call foo functions, you can see it actually has an EBP and ESP update. EBP will remember the previous ESP, the position. Then even though you try to do a lot of push of ESP, it doesn't matter because you have an EBP. And when you call MI, you update again. You update your EBP to the previous ESP. Then you can use this ESP to do a lot of different push stuff for your code. Then after you finish, you can do MI again, MI again. So actually you just, every time you do a functions code, you update the EBP and ESP. And right now you finish the last code of MI, you want to go back. How you go back? Even though you do a lot of push, you can still go back. Why? Because you have an EBP. It is EBP information stored the previous position of your ESP. So after you return, you can get this back. After return, you can get this back. After return, you can get this back. And you can call the MI again to update EBP, ESP. And when you finish, it's go back again, and go back again, and so on. So this is just one example how your assembly actually work. But if you want to write a program in assembly, you need to keep in mind when you do a function call, function return, you need a smart way to remember where's the previous ESP and EBP. And of course, you might think, okay, how I remember the previous EBP? I use EBP to remember the previous ESP, right? But if I use EBP to remember the previous ESP, how can I remember the previous EBP? You can use push, right? You can always push the EBP before you update the EBP to your new ESP or your previous ESP, right? So if you try to read the code in some way, in the future lectures, we will talk about the code a little bit. You will find this trick a lot. Every time we want to have a function code, what we actually do is we push the EBP, then we update the EBP to the current ESP. Then we can do a function code. Because after we do a function code, even though you do a lot of different stuff like push, you can always find the previous ESP by access the EBP. And when you find the EBP1, you can just pop. You can just do a pop, then your EBP will go back to the previous EBP. So we use this like idea to manage the function code, function return, to avoid to count the like a longest counting of how many push you actually do or how many pop. And also, if you can save these like a multiple pop in your systems, it will also save your program performance because you don't need to do these operations. All you want to do is try to get the data from one registers and go back to this reducer's memory address. You don't need to go to pop, use multiple pop to go back to the previous previous memory address, right? If you have one memory register to store this memory address, then you don't need to do a whole bunch of pop. You can just jump back. So this is the idea to use 2 pointers to remember your stack frame. And this is very, very smart techniques in assembly. Okay? Okay, so this is for today. I hope you enjoy it. Today we talk about the stack. In the systems, in your memory, you have a special like parts of your memory we call stack. For the stack, we use stack to implement a lot of like functions, function call, function return. We also use stack to do some push or pop to store the data. Some data, for example, register data, for example, some memory data. So for example, some constant data, we can use the pop, push and pop to remember these data to support your algorithm. But here's the things. If you only use one registers to like support this data management, the push, pop, and also call return, then every time you have a multiple push, for example, 3 pushes, you need 3 pop to make it back to the right place. Then you can call return. Otherwise, it will fail. Your program will fail to run. So in this case, actually, there's a small way we use different pointers we call base pointers. We use base pointers to remember the previous stack pointer's position. So after we finish the functions, we can easily make the stack pointers back to the previous location, then do a return. So we use this small way, this trick, to like make the performance, make the program performance better. Also make the programmer easy to manage this memory address stuff, this stack stuff. Okay, so I hope you got the idea for today. I hope you enjoy it. We will talk more examples in assembly in other videos. So understand the stack can help you understand the code. We will talk in other videos in the futures. Okay, so see you next time. The stack friends, stack pointers, base pointers, this whole set of idea is so cool.